Alrighty, so now that we know a little bit about probability models and simulations, let's actually apply some probability rules here. And the nice thing about probability is that there's a big chunk of probability that actually focuses on just drawing a picture or being able to explain your reasoning using some type of graph or diagram. So we have two that we're going to use here. Now, I need you to write down these symbols on your paper. This upside down N, upside down horseshoe, means and this represents an intersection. It's probability both events occur. Now, regular old horseshoe kind of looks like a U. This represents or, and this is called a union, which means either A or B occurs. Now, most ways that you'll see it on the AP Stats exam are going to be using a two-way table. And actually, it's my preference over Venn diagrams, but I'll show you both because why not? But here on a two-way table, it's very similar to a Punnett square you might have learned about back in biology. So remember, if this was being tall and this was having brown eyes, then this would be tall and brown eyes, and etc. Except you work with dominant and recessive genes in bio. Here we're going to work with events and their complements. So this would be event A, this is event B, and their intersection would be events A and B. That's this middle here of the Venn diagram. It belongs to both of the categories. Here, the blue section represents what belongs to A but does not belong to B. B is anything in the red circle, A is anything in the blue circle. And so the other sections of this also follow. Note that there are four sections that we're concerned about when using these probability rules. And so all of event A, everything in the blue circle would be what is A and not B, and what is A and B. Notice that both of these have an A, so they're in the blue circle. Anything that's not in the blue circle is not event A, and that brings us to our first rule here called the complement rule. So the complement rule says anything not in our area of interest is the complement. So either A does happen or A does not happen. So technically the rule says this, either A happens or A does not happen, and since it either does or does not happen, that equals 100%. But the way you're going to see it on the AP exam, and the one I want you to kind of get in your brain here, is that the probability of A complement, notice that here I'm just solving this backwards, just equals 1 minus the probability of A. So if I want the complement of A, I'm just going to subtract out A from the sample space. It's kind of like taking a noodle and you break it in half or break off a chunk of it. You either have one or the other, but if you put them back together, it's still one noodle. It's kind of like a spaghetti theorem, if you will. So this is a complement rule, and this is not on your stats formula sheet. So you do have to memorize this one, but it just means either A does or does not occur. Next up, we have the general addition rule, and this actually is on your formula sheet, so you don't have to bother memorizing this one. But this says to find the probability of A or B, so to find the probability of A or B, I want anything that is in a section of the Venn diagram or anything that belongs to either one of those events. So notice that all of the yellow region would be all of the yellow circle. So that is the probability of A. And then I'm adding the probability of B, the blue circle here. Sorry, I'm saying it backwards. Okay, the yellow shaded circle and the blue shaded circle. So I'm adding both of those because I want either all of event A and all of event B. But notice that I have an overlap here. So when I do A or B, notice that there are really only 3 sections of interest. But if I were to just add all of A and add all of B, I end up double counting this area here, this A and B, which means that in order to find the total probability of A or B, I only want this one time, so I'm going to subtract it out. So as of now, we're adding 2 of them in, but the reason I'm subtracting is because this green area has been double counted. Notice on my shading here, it was shaded once in yellow, then again in blue, but I only need one of them because there's only 3 sections here. So those are our probability rules, the very fundamental ones. So we have a two-way table, which helps us to organize our data. The complement rule, which says the probability of A not happening is 1 minus the probability that A happens. Then we have the general addition rule, which says the probability of A or B is equal to A plus B minus A and B, because again of that double counting. So let's take a look at an example here. What is the relationship between educational achievement and home ownership? A random sample of 500 people who participated in the 2000 census was chosen. Each member of the sample was identified as a high school graduate, or not, and as a homeowner, or not. We know there are 340 individuals who own a home, 310 individuals who are high school graduates, and 221 individuals who are a high school graduate and a homeowner. So let's define our events here. And again, this is just proper mathematics, is defining our X, what we're looking for. So here, we'll let H be the probability, or H be the event that the person is a homeowner, an owner of a home. And we'll let G be the event that the person is a high school graduate. So this will just help me now with my formula since I'm just going to be plugging them in essentially, or just using the information given. So here's going to be my first one. So I'll just draw this two-way table right here. Oh, there's a reason I do not teach geometry. And I'll put in a Venn diagram as well. And I do not know why it was this large. Don't ask me questions I don't know the answer to. Okay, that circle's going to bother me. All right, so let us organize our data by what was given to us in the problem. So I have they are a homeowner or are not a homeowner, and they graduated from high school or they did not graduate from high school. And in the end, it doesn't even matter, Lincoln, anyways, in the end, there should be 500 people that are in this sample in totality. So I was told that there are 340 individuals who own a home. So I'm going to go here to own a home. There should be 340. But notice now my complement rule, H plus H naught should equal the total. So if 340 out of 500 own a home, then 160 do not own a home. I was also told that 310 are high school graduates and 310 of the 500, which means 190 of them are not high school graduates. And then lastly, those that are high school graduates and own a home is 100, just kidding, is 221. So now you're thinking, well, how are you going to find those missing spaces? Well, I'm so glad you asked. In theory, we can actually use now this total law of probability. So look here, there's 340 total people who own a home. And of those 340, I know 221 of them own a home and graduated from high school, which means 340 minus 221 using this complement rule says that there's 119 people who own a home but did not graduate high school. And now we're going to go in the in the horizontal direction. So here, 221 people own a home and graduated high school, and 310 people graduated high school in total, which means 89 people graduated high school but do not own a home. And then now for the last spot, if you've done this correctly, whether you go vertically or horizontally, it should be the same number. So for us, it should be 71 people that do not own a home and did not graduate high school. So I'm just going to, I was going to color code, but we don't need all that. So here is the 221 that belong to both and the 71 that belong to neither. Now remember, this is event A and this is event B. So for all, sorry, not A and B, it's because I'm a math teacher. Those are my go-tos. So here's H, here's G. Here's H and G. So the total that own a home should be 340, and I know 221 of those. Here, 119 own a home but did not graduate high school. So notice they're not in G's circle because 119 people only own a home. They did not graduate high school. And same thing here in this section. This is going to be the 89 people who did graduate high school, but they do not own a home. So we can see here the connection between the different sections in the Venn diagram and the two-way table. So let's find the following. Let's use our proper notation. So the probability of not owning a home is going to be the complement rule. So that's going to be 1 minus the probability you do own the home. Now remember back to lesson 4.1, all probabilities need to be between 0 and 1. And if I do 1 minus 340, it's not negative 339. Recall, it was 340 out of 500. So that'll give me 160 out of 500 or 0.32 or 32%. On the AP exam though, we'll kind of stick to fractions and decimals. At a minimum, you do need the fraction. The decimals just kind of fluff at this point. Now let's find the probability of owning a home and not being a high school graduate. So you want to own a home and we want you to not be a high school graduate. We want you to be a high school graduate, but for the sake of this question here, well, we identified this as 119 out of the 500 total people, or about 0.238. So that is how many people do not own a home and they did not graduate high school. And then lastly, we have the probability that you own a home or you were a high school graduate. Oh, the probability of a hug. Now, notice here what I'm doing. I'm just writing out what I'm looking for. I'm giving my formula, showing my substitution, and then showing my work. That's about 4 steps in the process, and generally that's going to be enough to get you full credit on the AP exam. So here, notice that the upside down is the and. Here, the or is this horseshoe. So since it's or, it's a general addition rule. So I'm going to take the probability that they own a home plus the probability they were a high school grad minus the probability of both. So here we will take the probability that they own a home was 340 out of 500. The probability that they graduated high school was 310 out of 500. Sorry, looking at my notes here. And the probability that they own a home and graduated high school was 221. And this is actually going to give us a value here of about 429 out of 500 people. Or, again, you could use the decimal representation, which is going to be about 0.858. So these are just the different rules of probability here: the complement rule, the intersection, and the general addition rule. Don't bother memorizing formulas. You can just always reference the table and add up the different probabilities. What's important on the AP exam is just communicating what you're doing. So again, that is, what are you looking for? Notice my first step is the term. The second step is showing what I'm doing, either through formula or through substitution. You can see that in all three of these problems here. And then the last step is just a correct answer, which if you do what you're supposed to do, they're all going to be correct answers. So let's take a look at another example here. And I'm actually going to have you pause the video to try this one out for yourself. So go ahead and pause the video, try this problem out, reference the last example we did, and then we'll come back together to review it. So go ahead and pause now. Alrighty, so hopefully this wasn't too complicated. We define C as the fact that the home has a cell phone and L as the household has a landline. Here is either our Venn diagram or a two-way table. Again, preference for the two-way table. But in true math teacher fashion, I gave you an example and I didn't cover how to do it with relative frequencies, but that's okay because it follows the same way. Instead of adding up to the total raw frequencies, it's just going to add up to 100%. So notice 78 plus 22% is 100%, 80% plus 20% is 100%, and those same properties apply here. Now, the probability that they have a cell phone only might have been tempting to do probability of just C, but in event C, you have those who have landlines and those who do not have landlines. So since we just want the cell phone only, that would just be the 20%, those who have a cell phone and they do not have a landline. Next, we want that they do not have a landline or they do not have a cell phone. Again, that's just an identification. That's going to be here at 0.02. And lastly, the wording here is a little wonky, but it says find the probability that the household has neither a cell phone or a landline phone. So neither a cell phone or a landline phone. And look at that, Mr. Pinto made a mistake, but it's okay because we can correct these together. So let us take this here. And this is why I write out my formulas first, because it just helps me to visualize everything. So they do not have a cell phone or they have a landline phone. Neither a cell phone or a landline. I think I did it right initially. Neither a cell phone or, if we just want the probability they don't have either or. So the probability they did not have a cell phone was 0.2, and the probability they did not have a landline was 0.22, and the probability that they did not have a landline and they did not have a cell phone was 0.02. So summing that together will give me a 40% chance that they either did not have a cell phone or they did not have a landline. So the wording gets a little bit wonky. I hope, fingers crossed, on the AP exam the wording won't be this wonky, but for the majority of our practice and in-class examples, it will be pretty clear. This idea of nor usually means you don't have this one or you don't have this one. So here, that you neither have a cell phone or a landline phone. And the OR rule, general addition rule, applies to any of the ways that we do it because it always follows this general formula. You're just subtracting out the overlapping area. So that's a little bit more on the rules of probability. We'll keep practicing this throughout the rest of our lessons. It's going to wrap up lesson 4.2. So here's just a few summaries for you. We use a two-way table which has connections to the Venn diagram. You can see each of the sections here that matches. And then we learned about the complement rule, which is the probability of A not happening, as well as the general addition rule. And again, it's not just going to be for A or B. These are just general terms. It could be for B complement. This could be for A complement or B. This could be for A complement or B complement. But the rules just always follow the same trends here. So regardless of what you're doing, as long as you've identified the formula to use, you are good to go to substitute and work out that answer. So we'll keep practicing. And in the next lesson, we're going to learn about a new type of probability called conditional probability. So stay tuned.